Hi. Today I'm just gonna talk about what I learned today. I wasn't able to learn something like really deeply, so I'm just gonna recap like the important part of the computer science of it. So, um, if you learn how processor works, because the why you have to learn about how processor works because basically computer science is it's just like operating system or data structure or algorithm, those kind of thing of it. If you're trying to make some kind of simple operating system, you really have to understand about hardware, how CPU works, and how CPU fetch the instruction from the memory. So that is really complicated. So you have to look at how processor works. Actually, like there's so many things about processor, but you can think of like processor. There's like three actions of processor, three actions, which are fetch and decode and execute. So that's very simple, right? But 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 the thing is that why we need such kind of fetch and why we need such kind of decode and why we do the execute. But I'm pretty sure we already know why we need some kind of execute. But the thing is that why we need such kind of fetch? It is just like fetching some kind of resources from the network or the others, and this fetch is so actually it's just a getting instructions from memory. But why? Because um, the processor, the CPU, can execute one instruction per time. So what do you mean instructions? So instruction is very simple. It's just a command that you declare for some kind of action with it. Example, move or pop or push or whatever. So that is called the instruction. So actually the move is not instruction. Move some kind of AX or 3 or this is the instruction. So the move is just some kind of like uh OP code of the assembly, so whatever. But instruction is just the command that you declare some kind of action to the CPU because CPU is just the simple machine that wait for your command and instructions, right? But CPU, as I said, CPU can only execute instruction just one time per time, and your big software example, even though you have small software, you probably have like multiple of instructions, like example 8 of instructions, 8. But you have to store some kind of 8 instruction because the CPU can only handle the one instruction per time. But where to store it? We store commonly in the memory of it. I know there's kind of RAM or ROM or those kind of things, but we're just gonna say memory because just keep it simple. And so basically, there's kind of write or those kind of thing. And I think the most important part of the the kind of like the computer architecture is just ask why. Example, fetch. What is fetch? Fetch is just like um, getting this instruction from the memory. Why? Because we can only execute instruction per time, per operation, and we need to store feature command aka instructions. And that's great. Yeah, but why? Why we need to store the feature commands to the instruction? But the thing is that also instead of asking why, we can also ask how. But how we did it? I don't know. Like if you look at the like CPU thing is, if it's like processor, um, there's actually some kind of chips on it, some kind of pin on it. So this pin is kind of like for this just a wire. There's some kind of like multiple pin of it. So there's some kind of multiple pin of it. And there's a purpose of the pin. And I forgot the most famous pin was, but whatever. So there's pin of it, and to be simplified, there's such a thing as memory. And to connect this kind of processor to the memory, you have to understand the address lines. What is address lines? Computer, to build a computer, you have to understand the hardware thing, like address lines. Address line is just the hardware, but it's just a group of hardware wire that connects to the memory, because your processor has to be linked into memory, because the processor has to get the instruction from the memory. So that is why address line is important, because you can also send the data from the address lines. Address lines, it sounds really complicated. It's just basically just the highway, or road that receives only 0 or 1. So basically, if your processor have 10 address lines, that means that you probably can send this kind of maximum data of 124 data. So that's really simple, right? So let me give a specification of it. You have some kind of 10 address line processor, but you have like 128 times 8 memory. But the question is how many memory you need. How many memory chips you need to have. So that's really simple, because I forgot the one. The unit of the memory is mostly just a byte. So if it is this 8 is 8 bits, so convert into byte is kind of 1, and of course this 128 is the number of the addresses. So 128 times 1 byte, because this 8 is just kind of unit of the addresses. So that means that we have 128 bytes we have 128 bytes of storage, and that's it. And so how many memory chips we need? 124. I think it was like divided 128 divided by 128. Wait, hold on, 1024 by 2. I think it was like dividing to 1024 divided by 8. So or the 2 square. Yeah, it was 2 square 7, because 2 square 7 and equals to the 128 byte 28. So we need some kind of other 7 address lines, or hold on, I forgot it. I forgot it. I think I have to study more about it. I think it was like I think 1024 divided 128. I think there was the formula of it. So there's gonna be 8 chips, right? 8. No, it was not 8. No, it's not. I think that's not. I forgot the word. I forgot it. 128. You have 10 address lines, so 2 square 10 equals to the 124 divided 128 is equals to the 4 divided by 4. Wait, hold on. Yeah, it was 8. It's 8. I think I'm correct. So that means that we need to have 8 chips of it. So that's kind of fun of it. So this is kind of theory, right? So, and you have to really make it. You have to you already understand the theory, and that's good. But I think what I really think of computer science is it has to be practical. You have to make it. So what I did was, if you look at here, I make it some kind of the I virtualize hardware specification using front end part. So example, if you look at the CPU part at the memory, and memory receives CPU, and if you look at here, when it receives some kind of CPU, and it converts the word size of it, of course, location of chips, and it change in, so it eventually able to get the size of the buffer. So, and the and I already made the number of chips from formula. And if you look at here, the formula is the total address of the memory and divided the memory per chips. So yeah, and that's the formula I made. So I think this is how I did. So I implemented the whole kind of formula, the theory, into front-end part using some kind of class code. So that the reason that gonna be work because there's kind of buffer API or buffer thing is buffer. There's kind of new buffer thing in JavaScript, so you can just put some kind of bytecode into buffer. So that's really how I did. I don't know if that's gonna be a wise idea, but I think that really hurt me to understand and not really easy to forget. So this is it. So have a nice day. See you next time. Bye bye.